Hello and welcome to another video. In today's video, we're going to be going over the idea of the average value of a function. So, what's important for you to know? Well, the average value of a function is going to be given by summing up a ton of different points. Well, and then dividing them by the amount of points. Well, I haven't shown you the work for this, but eventually you can derive this formula that f average is equal to 1 divided by b minus a times by the integral from a to b of f of x dx. And that will give you the average value of that function on the interval from a to b. So we're now going to use this formula here to calculate the average value of these functions. So we have to always start by taking the derivative since we're working with, or really what I want to do is set this up. So this is going to look like, or f average in this case, is going to be 1 over 2 minus 1, or 2 minus negative 1, which is 1/3. And we're integrating from negative 1 to 2 of 3x squared plus 8x dx. Well, moving over here, this is going to be the same thing as 1/3 times by x cubed plus 4x squared evaluated from 2 to negative 1. Alright, well, we still keep the 1/3, but this time now we have to evaluate it. So 2 to the power of 3, that's 8. 2 squared, that's 4, times by 4, that will give us 16. Then we're subtracting it at the lower bound, which is going to be negative 1 cubed, which gives us an answer of negative 1, and then plus 4 times by negative 1 squared, which in this case is going to give us plus 4. So we now can evaluate this, so we get 1/3 times by 8 plus 16, that's 24, minus 3. So we get 21. So our answer for the f average is equal to 7. For this next interval, we have to start by using some u substitution here to actually just find the antiderivative. But we're still going to set this up first. So this is going to be the same thing as f. I do not want to be using blue. Let's use green, why not? F av is going to be equal to 1 over 4 minus 1 is 3 times by the integral from 1 to 4 of e to the 1 over z squared dz. Well, we're going to say u is going to be equal to 1 over z. So then our du is going to be equal to 1 over z dz. And now we just need to solve for dz, so we're going to just multiply z over, or sorry, this should be a negative 1 over z squared. So we're going to multiply this over, so we're going to get negative z squared dz is equal to our differential du. So now what this integral, and let's real quickly solve for the points here. So we get u evaluated at 1. That's going to just be the same thing as 1. So plugging in 1 to u, we get u is equal to 1, and then plugging in 4, we get u is equal to 1/4. Which is not ideal, but we'll deal with it. So we get 1/3 times by the integral from 1 to 1/4. I suppose that is possible for happening. Times by, and because we have to divide this out, we get negative e to the u du. Well, I'm just going to bring out or cancel the two negatives for swapping the bounds here. So we really get 1/3 times by the integral from 1/4 to 1 of e to the u du. This will then give us an answer, or evaluating this is going to give us 1/3, and the integral of e to the u is just e to the u, so I'm just skipping a step here. E to the first minus 1/3 e to the 1/4. For this third integral, we're going to first take the antiderivative and then we'll evaluate it. So we'll say u, in this case, because we can clearly see the derivative of u here, or the derivative of the natural log here, we're going to say u is equal to the natural log of u. We're going to say our du is equal to 1 over, or sorry, this is going to be very confusing, so I'm going to actually call this z, a new variable called z. So we're going to say that dz is 1 over u du. Now we just have to solve for du, which in this case is going to be u dz. Then we're going to actually finally set up this integral, which is going to be the integral from the natural log of u divided by u dz, or du. We're going to then sub in our z. Oh wait, give me one moment. I need to real quickly find the bounds. So, in z, this is going to give us the natural log of 1, which is 0, to the natural log of 5. So we're going to get 0 natural log of 5 of z dz. Alright, well, I suppose I have to evaluate this now. And this will give us our average, or our value, and then we'll have to divide this by the value of the, or the width of the interval. So in this case, we are going to get z squared divided by 2, evaluated from the natural log of 5 to 0. So, plugging in natural log of 5, we are going to just get the natural log of 5 squared divided by 2, minus 0, which is just 0. Then we have to multiply this just by the width of the interval, or divided by the width of the interval, which is 4. So we get the natural log squared of 5 divided by 8. Alrighty, continuing on. The mean value theorem for integrals. So, there's a mean value theorem for a derivative, but there's also one, interestingly enough, for an integral. So, the mean value theorem for integrals states that if f is a continuous function on the interval a to b, then there exists a number c within the interval a to b such that f of c is equal to the average value of f, which is equal to b over b minus a times by the integral of a to b of f of x dx, or other times also stated as f of c times by b minus a, and that is equal to the integral from a to b of f of x dx. Alright. So we want to use this mean value theorem to find the value c such that f of c is equal to the average value at the given intervals. Okay, well, for this first function, this is pretty easy cakewalk. This is going to be the same thing as, let's do a bit of algebraic manipulation here, t to the negative 2. So what this is going to look like is h average, which is what we first have to find, is going to be 1 over 2 times by the integral from 1 to 3 of t to the power of negative 2 dt. Well, f average is going to then be equal to the integral from 1 to 2. 1/2, apparently, not the integral from 1 to 2. I don't know where I got that from. But 1/2 times by negative t to the power of negative 1 evaluated from 3 to 1. So we get this value, h average, is equal to 1/2, and then in parentheses here we have negative 1/3 minus negative 1 over 1, which is just 1. So we get an answer for 2/3 inside of this right here. So we will get an answer of 2/6 is the average value, or 1/3. Okay. So now what we're going to do with this is we're going to set this equal to h of t. So h of, or 1/3, must be equal to 1 over c squared, because we're solving for the value c that makes h of t equal to this. So we are going to get, or let's take the reciprocal of both sides. So we will get c squared is equal to 3. That means that c must be equal to plus or minus the square root of 3. But the minus part is not within the interval, so we get the answer of c is equal to the square root of 3. And that would be our answer. Alright, for this next function, now that we've already solved for the c is equal to the square root of 3, we are going to say that we're actually going to set this one up just a small bit differently. We're going to set it up like we're solving for the c from the beginning. So we're going to say c plus 1 cubed is equal to 1 divided by 2 times by that integral from 0 to 2 of x plus 1 cubed dx. Well, in this case, we have to use u sub for this. Well, in theory, we could expand it out, but I don't want to expand it out, as that makes a mess. So we're going to say x plus 1 is equal to u. So that makes our du equal to dx. So we now have the c plus 1 cubed is equal to 1/2. And let's solve for our values of u here. So if I plug in 0, I'm going to get 1. So this is going to become the integral from 1. If I plug in 2 to u, we will get 3. Alright. Now we are evaluating this from u cubed, or not evaluating, but we're integrating u cubed du. So c plus 1 cubed is equal to 1/2 u to the 4th divided by 4 evaluated from 3 to 1. So c plus 1 cubed must be equal to 1/2. And then in parentheses here we will get 3 to the 4th, which is going to be 3, 9, 27, 81 fourths. minus 1 to the power of 4th divided by 4. So that's going to give us 1/4. So we will get an answer of 80 divided by 4, which is 20, times by 1/2. So we get 10. So we now know that c plus 1 cubed is equal to 10. But we need to now solve this expression for c. So we're going to take the cube root of both sides. So we get c plus 1 is equal to the cube root of 10. So then we must get c is equal to the cube root of 10 minus 1. Now you might know that the cube root of 8 is 2. And then the cube root of 27 is 3. So this is the cube root of 10 is greater than 2. However, because we're minusing 1, but we know it's less than 3, we know that this value here is going to be within the interval of g of 0 to 2. So this value of c is equal to the cube root of 10 minus 1 is going to be the average value of g on the interval from 0 to 2. Alrighty, well, now I just want to talk about some of the intuition for the mean value theorem for integrals. So really, what this theorem really gives us a way of doing is, let's say we have the entire area here. This entire area under f of x. We're going to highlight it or strike it through in white. Well, what the mean value theorem for integrals is, which is what we were talking about up there. Excuse me, I'm sorry. Says that there must be a value where, let's say there's a rectangle, and let's call this value h, where h times by a comma, or a times b minus a, because that's the width of the interval, is equal to the entire area under the curve. Now, what the mean value theorem truly states is that there must be a value c in the interval that is equal to the value h. So there must be a value f of c that is equal to h. So you can clearly see here that this is slowly going to become the mean value theorem for integrals. Of course, this isn't like a rigorous proof or anything like that. This is just more or less a visual description. Well, I hope you all have enjoyed this video, and if you did find this video informative, make sure to like and subscribe. We're finally going to be moving on in this next chapter to working with the techniques of integration, which I am looking forward to. Alrighty, well, I hope you all have a wonderful rest of your day and enjoyed. Goodbye.